Research on database language query method based on cloud computing platform. Reporter, Shao Gong. Abstract. Some database language query methods have the problems of time cost and resource occupation. Under this background, a database language query method based on cloud computing platform is designed. Convert the formally described information into data that can be stored, extract the semantic web hierarchy, and establish relationships with real objects, identify the potential association features of database words and sentences, restore the original orthogonal semantic structure space, build ontology annotation model based on cloud computing platform. Transplant HANLP's neural network dependency syntax analysis tool, and design language query methods. Test results. The average time cost and resource utilization of the database language query method design this time are 1720 milliseconds and 42.36% respectively, which shows that the database language query method design this time is more effective under the technical support of the cloud computing platform. Introduction literature proposed a database language query process analysis method based on data mining. It will identify the query target and query conditions through database semantic analysis based on the query statement segmentation array, build a semantic dependency tree, divide it into collection blocks, and convert the natural language query into SQL statements through comprehensive conversion method. On this basis, use data mining technology to locate user demand data in the database. The location data is extracted and fed back to the user to realize the analysis of the database language query process. The experimental results show that the method can provide accurate database services for users. Literature proposes a database keyword query method based on pattern graph. His method designs a combined network structure, which can effectively avoid redundant operations caused by redundant structures between candidate networks and traditional methods. At the same time, an improved candidate network generation strategy is proposed, which can avoid generating redundant candidate networks and reduce the traversal range, thus improving efficiency. Finally, based on the merging network, a merging network execution algorithm is designed to further improve the query efficiency. The experimental results show that this method can ensure that the query results are not missing. Extracting the semantic web hierarchy. The semantic network connects multiple entities through semantic relationships to form a directional knowledge network from the starting point to the end point. The relationship model uses the relationship table as a data structure, behavior tuple attributes, and field attributes to form a two-dimensional structure. Semantic web can not only describe video, image, digital resources and other content in the page, but also describe abstract resources such as time, behavior, space, and events, and declare the relationship between resources in the description. Semantic web has the following characteristics. The access to information resources is no longer limited to local, and it is more convenient to obtain a wide range of information resources through the network. In the hierarchical structure of the semantic web, the syntax layer, the data layer and the semantic layer are the core parts of the semantic web, which realize the semantic representation of web resources. Among them, XML realizes the structuring of documents. RDF uses triples, objects, attributes, values, to describe resources. Using this structure is conducive to automatic processing by machines. The basic idea of the word segmentation matching algorithm based on probability statistics is that the probability or frequency of adjacent words can better reflect the credibility of the composed words. RDFs describe the concepts and attributes of resources, and provide semantic relationships between concepts and attributes according to the conceptual hierarchy of ontology. The logic layer, the proof layer and the trust layer realize the logic reasoning function, and provide authentication and trust mechanisms. The digital signature technology is mainly used to trust and authorize the description, reasoning and certification of resources. As the upper structure of the semantic web, it ensures the security of semantic web operations and content to the maximum extent. Identify potential associated features of database words and sentences. The database implementation structure adds a spatiotemporal processing layer on top of the traditional relational database management system, and the data operations are completed through the spatiotemporal processing layer without any modification to the underlying database management system kernel. At the same time, this keyword-based text processing method is mainly based on word frequency information, and the similarity of two texts depends on the number of common words they have, so it is impossible to distinguish the semantic ambiguity of natural language. This spatiotemporal processing layer is responsible for the translation between the database language and SQL, and the optimization of spatiotemporal queries. All data requests must be processed through the spatiotemporal layer. The meaning of words is the weighted average of multiple meanings of words. The potential semantic structure is used to express the term in text, and the term and text are mapped into the same k-dimension semantic space, which is expressed in the form of k-factors. Therefore, the meaning of vector reflects not the frequency and distribution of simple terms, but the strengthened semantic relationship HF is constructed to act on temporal types, resulting in composite spatiotemporal types that can support past and future motion. For example, HF, points, MHMES, represents a space-time object whose motion before the current moment is a moving point, and is expected to be a moving line afterward. Construction of ontology annotation model based on cloud computing platform. In the cloud computing platform, one of the most important problems of cloud service ontology annotation is to maintain the consistency between the known cloud service documents and the ontology library that stores annotations. Consistency refers to maintaining the correctness between annotations and language expressions in cloud service documents. Database is the basis for computer to understand natural language, which makes it possible to realize the universality of interfaces. According to the applicable scope of knowledge, this paper divides the database into two parts: general database and special database. The general database is composed of a word segmentation dictionary, a general database dictionary and a synonym word forest, and is not affected by the application field. Finally, a consistent cloud service ontology annotation is generated to ensure the correctness of the user's cloud computing-based database language query in the first part. Ontology is the fourth layer of the 7-tier semantic web architecture. It is a modeling method for the semantic description of cloud services. Ontology uses a formal way to define the terms that have gained consensus in the field, clarify the relationship between terms, and use the hierarchy and relationship between concepts and attributes to express the semantic relationship between concepts and attributes. Design language query methods. The database language query based on cloud computing applies the retrieval conditions described by natural language to analyze and process in a semantic way, realizing the expansion of retrieval at the semantic level, and thus improving the recall and precision of the database language query process based on cloud computing. The process of database analyzing query statements expressed in descriptive language and determining reasonable and effective execution strategies and steps for them is called query optimization. Query optimization is an important part of query processing, especially for relational databases. The essence of query conditions is to limit the given database information, and the purpose of analysis is to express it in a standard structured form, so as to obtain the data records that users want. In imperative sentences, the query target often appears at the end of the sentence as a noun phrase structure. Therefore, when processing query statements, we use reverse order to scan forward from the end of the sentence. The query statement is limited in length, and the rule set is small and unambiguous. In this paper, an improved reverse maximum length matching algorithm is used to store the match target phrase into the target phrase set, and the entities in the target phrase set are stored into the entity set. Simulation test. Test preparation. The specific configuration of the test environment is CPU 2 quad-core GHCAMD Optron, TM, memory, 4 GB fully buffered DIMM ECC registered SD-RAM, hard disk, 2 Seagate, ST91468002SS, 146 GB 10,000 RPMs, operating system, Linux Red Hat, file system, ext3 page block size of 4096 bytes, compiler, GCC. Since the system is a restricted natural language interface, users should support in-scope questions as much as possible. In order to further verify the effectiveness of the database language query method design this time, take the query accuracy rate as an experimental index, and compare the methods of literature in literature with the database language query method design this time. The results are shown in Fig 6. It can be seen from Fig 6 that the maximum query accuracy of the database language query method design this time is 86.1%, and the maximum query accuracy of the document method and the document method are 73% and 73.5%, respectively. It can be seen that the query effect of this method is better. Conclusion. In order to solve the problems of time cost and resource utilization of traditional database language query methods, this paper designs a database language query method based on cloud computing platform. This paper focuses on the semantic annotation method of relational data, and realizes the association between words and database objects in the way of data semantic coverage. In addition, the tagging information of the conditional value of the question is added to the database language query method, and the NL2SQL task of Tab 1 EQ a dataset that may not directly contain the conditional value required by the SQL statement is decomposed into two tasks. Question parsing and text matching. In the neural network of question parsing, the separator determined by the column type is fused into the input of Roberta encoded to extract the column features. No additional calculation is required by the column attention mechanism. The text matching problem is solved by combining the editing distance and semantic dictionary. The experimental results show that the time cost and average resource utilization of the database language query method design this time are low, which indicates that the application effect of this method is good. Thank you.